Informal definition. When something is closed under an operation, it means that for any two members from the set chosen, the operation will compute to another member in the set. So for example, like on a larger set, if we're talking about the integers, which we often refer to as this z, the integers are closed under addition, because any two integers I add together, I will get another integer. So create a set that contains fewer than 10 numbers that's closed under addition. Well, let's just play with this a little bit. 1, 2. Is this closed under addition? Well, 1 plus 1 is 2, that's good. But 1 plus 2 is 3, and that's not in there, so let's add 3. But 1 plus 3 is 4, and 2 plus 3 is 5. So again, now we're... And I could go on and on. This is going to be difficult to do with just these numbers. So let's try some different numbers. What about 0? Is this closed under addition? Well, yeah, 0 plus 0 is 0, so that works. What about this one? 0 plus 1, yes. But 1 plus 1 is 2, so if any two members are chosen from the set, well, I guess these aren't two different members, so what about that? So I think this works. I'd be interested for you to tell me that it doesn't, but I could see negative 1 plus 0. I could see negative 1 plus 1. I could see 0 plus 1. And those all come out to be numbers in the set. So I could see this being closed under addition. Closure under subtraction. Does the same set work? Well, negative 1 minus 1 is negative 2. So that does not work. So this is not closed under subtraction. That is, I know, because 0 minus 0 is 0. Think of anything else that's finite. Again, a challenge to you. Closed under multiplication. Again, does this work? 0 times negative 1, 0. So my zeros always come out 0. What about negative 1 times 1? Negative 1. So that works. This is closed under multiplication. Division. Does this work? Negative 1 divided by 1 is negative 1. 1 divided by negative 1 is 1. Negative 1. 0 divided by 1 is 0. 0 divided by negative 1 is 0. But 1 divided by 0 is undefined. So this is not closed under division. But this would be. So the idea here is I want you to think, right? Not just do some stuff. I want you to think about what does it mean to be closed. How do you get things that when you do an operation to two of the members of the set that you're automatically going to get something else in the set? How do you construct these things? Right? So it's much more important to know how to construct thinking about how do I know if something is closed or not? How do I create sets that might be closed? So something to think about.